Okay, let us start with this separate lecture on analogy between linear motion and rotational motion. See, this is very important lecture to understand all about rotational motion in one within 15-20 minutes. So that's why I'm making this separate video for analogy between linear motion and rotational motion. So बघा मी नेहमी स्टुडंट्सला म्हणत असतो की जर लिनियर मोशन तुम्ही अगदी करेक्टली समजून घेतलं असेल यू कॅन अप्लाय सेम प्रिन्सिपल्स टू रोटेशनल मोशन जस्ट सम लिटिल डिफरन्स इफ यू अंडरस्टँड then totally we can understand rotational motion at a glance. See these figures, this is a linear motion where this particle आता साईज काढली तर खरं तर हे पार्टिकल आहे आपल्याला माहिती आहे पॉईंट मास आपण कन्सिडर करतो इफ यू अप्लाय सम फोर्स हिअर apply some force here so body displaces by this some distance. Yes, there may be a possibility of where acceleration, yes, constant, or acceleration zero. If velocity is constant then acceleration is zero. बघा अगदी कायनामेटिकल मध्ये जर गेलो कायनामेटिक्स मध्ये कम्पेअर करू पण त्याआधी लक्षात ठेवा व्हॉट इज अ कॉज या सगळं मोशन होण्यासाठी जे कॉज आहे who causes the linear motions remember force causes linear. So similarly, who causes this type of rotational motion? बघा इथं काय होतंय particle doesn't change their orientation. They're moving, yes, moving with such velocity and with the same angular velocity omega. So here cause is a torque. Cause is a torque. So cause of linear motion is a force and cause behind rotational motion is a torque. Okay. So torque basically again force into some distance. We have studied this all. So that is again a effect of force. So ultimately cause behind the rotational motion is also force. But that force is strengthened by some radius that gives a torque. Okay. Now kinematics upon the consider केला. We are having these three equations. V equal to u plus at. What is this u? You know this is the initial velocity. V is a final velocity. T is a time and A is the acceleration, which is basically a tangential acceleration. V square is equal to U square plus 2AS. S is equal to UT plus half AT square. Okay, these are the three equations we can say kinematical equation to control a linear motion. So similar equations are here and also we have studied relationship between these two. V is equal to R omega. Just similar, S is equal to R theta. What is this theta? Theta is the angular displacement. बघा आपण इथे एक फिगर काढूयात. Just circular path आपण काढलाय. Let us say at some instant particle at this point, just like here, just like here. At after some instant particle goes here, just like this. So this travels angular displacement. So initially there will be a initial angular and final angular also we can take. But see, this is the overall angular displacement. This is angular displacement. This is a linear displacement. S equal to R theta. V equal to R omega and A equal to R alpha. So this is a linear quantity of acceleration, angular quantity of acceleration. So now similar equations are these equations are what when acceleration is constant. आपण याला काय म्हणतो युनिफॉर्म uniform acceleration motion. If this is a uniform acceleration motion, then these equations control whole uh, yes top of the linear motion. So similar equations are possible here. So omega final, just like a final velocity, omega initial plus alpha into t. Omega final square is equal to omega initial square 2 alpha theta. And here theta is equal to omega initial t plus half alpha t square. So these are when alpha equal to constant. When alpha equal to constant means just like a acceleration is constant, linear acceleration constant. This is when angular acceleration constant. When we also studied when v equal to constant, then what happens? Acceleration becomes zero. Acceleration becomes zero, and displacement becomes s is equal to just velocity into time. So similarly here, when omega is constant, angular velocity constant, then theta becomes equal to omega. This is another analogy for these two kinematical equations. So for any nth second, we also have calculated in linear motion s nth. What is the equation of s nth? You can recall u plus a by 2 2n minus 1. So similarly, here also we can calculate this theta n. Okay. So this see this the beauty of this analogy is very. So this and हे याच्यामुळे काय होतं लक्षात घ्या रोटेशनल मोशन अगदी कळून जाते ऑलवेज कम्पेअर विथ द लिनियर मोशन सो हिअर ओमेगा plus alpha by 2 in stem becomes 2n minus. So this is whole about a kinematical data. Initial kinematic data हा आपण असा compare करू शकतो. Analogy करू शकतो. Similarly, जर हे acceleration constant नसेल, if acceleration is not constant, then what happens? If acceleration is not constant, okay, then we have to calculate velocity using a differentiation ds upon dt, and acceleration is given by differentiation of velocity, okay, or double differentiation of displacement. So just similar, when alpha is not constant, then what happens? Then omega becomes yes d theta by dt, and alpha becomes d omega by dt, or you can easily now judge d2 theta upon dt square, dt square. So when it is not constant, then it's okay, you have to go with the math. So this is a total, you can see if acceleration constant, if velocity constant, and if acceleration are not constant, then you can use these similar equation. Okay. So now moving to kinetics comparison. What is a kinetics comparison? So kinetics comparison what? Just like a Newton's first law of motion for inertia, there is a inertia concept of inertia, which is nothing but which is nothing but mass. What is this inertia? This is opposition to change of state. So similarly here opposition to change of state is a mass moment of mass moment of inertia, mass moment of inertia, which again depend upon mass. So this is nothing but I m is equal to, we have studied this, m r square, okay, m into r square. So this is another step. First is a cause of linear motion is a force, cause of rotational motion is torque, and second inertia is this. In case of linear motion, the inertia is a mass. In case of yes rotational motion, it is a mass moment of inertia. What does the inertia? Inertia opposes the change of state of linear motion. Similarly, moment of inertia opposes change in the state of rotational motion. Change in the state of rotational motion. So Newton's second law becomes F is equal to mass into acceleration. बघा याचा counterpart कोण आहे इकडे? Torque is equal to mass moment of inertia into alpha angular. If you recall impulse momentum theorem in case of yes, in case of linear motion, so we can write summation F into time, which is the impulse. When force is acting, when large force is acting for a very short time, that produces the impulse, which is a product of force and time, is equal to change in its momentum. Change in its momentum. At the same time, you also do this analogy. This is force is a rate of change of linear momentum. Is a basic statement of Newton's second law of motion. Force is directly proportional to change of momentum. So here again coming to impulse momentum theorem, summation F into delta P, that is summation F into T, final momentum minus initial moment. Now same angular impulse momentum, what? Angular impulse moment, angular impulse momentum states again same, that is summation of torque we can say into this time is equal to change in angular momentum. So that gives summation of tau into t is equal to lf minus. So this gives, again we can modify this. This becomes mv minus mu, or taking m common, v minus. Same process here. Same process. I am omega final. I am omega initial. Or we can take common I, m for mass moment. omega final minus. Yeah. See, this is one of the kinetics. So we have studied also work energy theorem in case of linear motion. So what is work energy theorem? Work energy theorem. Here, work energy theorem. What is the work energy theorem? Summation of work done is equal to change in kinetic. What is the work done here? Summation of force into its displacement. Here it is half mass v square minus u square. So similarly, for this case, summation of work done is nothing but summation of tau into theta. So see, force into displacement is the work done in case of linear motion. Here torque into angular displacement is the work. Tau into theta, the yes, angular work done. Change in rotational kinetic energy. So this becomes again 1 by 2 I m we can take omega final square minus uh, initial. Okay, so linear kinetic energy is half mv square, rotational kinetic energy is half I omega. So we can calculate power even. So power always equal to force into velocity. In linear motion, power is force into velocity. Okay, so F into V. In this case, power, if you want to calculate similarly, instead of force, torque, instead of velocity, tau omega. So this is nothing but 2 pi n omega divided by 60 if n is in RPM. If n is in RPM. So now coming to yes, conservations of law. So we know that force F is equal to force F is rate of change of linear motion. When this F is zero, or we can say this resultant force is zero on a given system, then this yes dp by dt becomes zero. It means momentum is constant. Linear momentum is constant. So mathematically you can yes write like this. Mathematically it becomes initial momentum is equal to final. So mu is equal to this is called law of conservation of linear moment. We have used in several situations. So similarly, just copy this. Torque is equal to rate of change of angular moment. Rate of change of angular momentum. If this net torque is zero, okay, summation of torque it becomes zero. Then once so this dl by dt is equal to zero. That is momentum become constant. So finally, what becomes initial momentum? I m omega final is equal to yes I initial. But here you have to put I initial and final. So because it has some yes changing in it. We have studied in law of conservation of. And lastly, just I want to tell you how to calculate torque and angular momentum. There is also similarity between torque and this. So torque is always remembered. Torque is calculated the cross product of the position vector and force. And this angular momentum is also cross product of this R and linear, and both are directed as per right hand rule. So rotate vector R in the direction of force. So thumb indicates direction of torque. Similarly, rotate radius vector in the direction of momentum, that is in the direction of velocity. That gives us yes, that gives us a direction of angular momentum. And mathematically both are calculated by yes way of the determinant. You can use determinant to calculate yes these vector. बघा थोडंसं बघूयात आपण एल कसा काढायचा अँग्युलर मोमेंटम कसं काढायचं अँग्युलर मोमेंटम just calculate in this way taking mass as a common. This is a determinant vector I j k unit vectors. These are the coordinates x y z, and velocity coordinate vx vy, and so L is r cross p. Okay, is L is nothing but r c r cross p, but p is what? R cross, this is a mass, that's why we can take this is m out of this, and in bracket we can take r cross b, r cross b. So r may be the xi plus, yes, r may be this vector. R is, in three-dimensional xi plus yj plus zk. Okay, this is cap, cap, and cap. So these are the unit vector. And similarly, velocity vector is also vxi plus vyj plus vz. And this gives a result. This gives a result. So in this way, we can calculate angular moment. And also, when theta equal to 0 or theta equal to 180, they are parallel or anti-parallel, we can say. So there will be, yes, there will be zero torque, zero angular. If theta is 90, we get a maximum angular momentum and maximum torque, even though maximum torque. Okay. So as per the angle. So it follows all laws, yes, all rules of the cross product, all rules of the cross product. So this is a recap of this particular chapter. If you able to understand this all analogy, then you can solve any problem on rotational motion. Okay. So let us stop here for this small lecture.